Okay. Hello, everyone. My name is Gabby Reppert, and I am the co-chair of the Strengthening Committee in WIN and also the vice president of Continuous Management Institute. I'd like to welcome everyone to our webinar on the Human AI Alliance, Awakening a New Era in Nuclear Technology. This presentation is part of our webinar series for the 2025 Professional Development Week webinar. So today we're exploring the exciting and promising opportunities of the use of artificial intelligence in nuclear energy. Nuclear power has always been built on accuracy, safety, and innovation. And as we face growing energy demand, decarbonization goals, and a wave of digital transformation, AI is emerging as a powerful tool to help us meet the moment. It's not here to replace expertise, it's simply here to amplify it. So in this webinar, we'll look at real examples and practical opportunities and start imagining what the future of AI-enabled nuclear excellence can look like. So first, let me welcome and introduce our speakers. Teresa Clark is the Chief Nuclear Officer at Everstar, a US startup developing AI solutions for the nuclear industry. She previously spent over 2 decades at the US NRC, where she led licensing and oversight for operating in new reactors, nuclear materials, and fusion energy. Teresa holds degrees in material sciences and engineering from the University of Maryland and remains active in student mentoring and community service. Archie Manoharan is the Director of Nuclear Technologies at Microsoft, leading efforts to advance next-generation nuclear energy solutions. With a background spanning energy startups and global corporations, she brings deep technical expertise and a passion for sustainable innovation. At Microsoft, she is driving initiatives to integrate nuclear technologies into the company's clean energy strategy and broader carbon reduction goals. Next, we have Nelly Babayan, and she is the AI director at Microsoft, where she leads AI initiatives in the US federal agencies to drive mission impact. She oversees cross-solution teams and guides secure, mission-focused AI adoption across government programs. With a diverse background spanning think tank research, university lecturing, and published academic work, she brings deep expertise in policy, technology, and applied AI. And last but not least, we have Laura Dudes, who is the Vice President and Regulatory Affairs at the Nuclear Company. She brings more than 30 years of expertise across nuclear operations, licensing, and oversight. Previously, she served as regional administrator at the US NRC's largest field office, leading more than 200 staff responsible for safety oversight of 35 reactors, full cycle facilities, and new reactor construction. She has represented the US in international nuclear forums and is known for driving mission-focused, innovative regulatory leadership to support safe and secure nuclear energy development. And so with that, let's get started with our first speaker, Teresa Clark from Everstar AI.
It's a pleasure to be with you. I was really tickled when I was invited to join the seminar because I am a woman in nuclear and I do things about AI on a daily basis. So it really couldn't have been a more perfect fit. So as Gabby mentioned, thanks for the great intro. I've been in nuclear for over 2 decades at this point in a ton of different roles and seeing both the good and the bad of the innovation and of the sort of horrendous manual labor that we all do with copy paste and beating things into submission and trying to find the references that we need. And when I left the NRC this spring to join Everstar, it really gave me an opportunity to make the situation better for everyone and be able to automate things, to find things faster, and just really compress timelines and costs. And so the piece that they asked me to talk about here today was one piece of the AI tools that we're building for the industry about analyzing drawings and schematics. And I promise I will get to that so that they don't kick me off of the panel. But since I was going first, I thought I'd give you a little bit of background on how AI can be used in nuclear in general. And then I think you'll see a little bit of a different spin on each of those from the panelists. So I'll zip through some of the background, but I think it helps level set us all on what we're talking about when we're talking about AI and nuclear. And just for those of you who are a little bit trepidatious about AI and nuclear, this is not Skynet running your nuclear power plant. We are a long way from anything that's going to be autonomously doing things in safety related ways. So don't worry about that. At least when you're talking to me, you're talking about paperwork and making paperwork easier. So low stress, relatively low risk, and really high return on investment types of things. So, okay, great. So like I mentioned, I'm working for a company that is focused on that real sweet spot of using AI to accelerate the workflows that we all know should be accelerated in nuclear. And by doing so, we really see the opportunity to cut costs by an order of magnitude because we're doing, whether it's reading drawings, doing manual research through documents, other writing and rewriting tons of reports or reviewing other people's reports like I used to do, you know that there are ways that it could be more effective. And so that's what we're all about. And we're all about building solutions that are as accurate, complete, and explainable as we know all of our safety significant jobs demand. So kind of as just as the big picture, again, to get us all in the same playing field for this conversation, we are talking about baby steps into something new for some of us, and the AI that we can use to really drive toward the outcome that I set as the North Star. And so where AI tools, not just mine, but anybody's, can help you out with in different ways are really navigating the complexity of the documentation that we all have to deal with, and then using that to help you get ready to do whatever you're trying to do, whether you're drafting a license application or helping out with construction and operations, like some other people will tell you about. All this stuff can get more simplified and more user-friendly through the use of AI. And then you can do all sorts of other things once you have that framework and really go toward repeatability and the sorts of economies of scale that are going to be necessary if nuclear takes off the way we hope it will in this country. Next slide. So why are we even talking about these sorts of things? I talked to a lot of utilities, probably a lot of your companies. We've been chatting along the way. And again, whatever tools you're talking about that will help you do your job, they're clamoring for these sorts of tools because there's not enough people to do the work. We've been talking for years about the retirement tsunami and knowledge drain out of the nuclear field. And so nobody's worried about the robots coming to take your jobs. They are saying, I need help. I need to amplify my team and do more with less. And so that becomes very cliche, but an AI tool can be a way to make that cliche come to life. And then whatever you do, because we're in nuclear, it needs to be super secure. So that's always something that you should ask whatever provider how they handle it. And it should be simple enough that people actually want to use it, because otherwise you get no return on your investment if nobody's using it and it's just sitting there. And all of this can help you have not just more efficient outcomes, which everybody wants, but also higher quality outcomes, which also I think everybody wants in nuclear. And this is really something that can be done with the sorts of like checking through things, self-validating, making sure that it's right, versus what you and I have always done in sort of a copy paste mode. You fix it here, you don't fix it there, you end up with inconsistencies. Somebody gets you for that, whether it's the regulator or your boss. And so anything that makes that easier is better. So whatever you're doing, and this will come to bear when we're talking about schematics as well, you're trying to find some sort of information, you're trying to make some sort of judgment, and you're trying to write about it somehow. And so on this topic of managing drawings and understanding what it is, for example, if you are trying to figure out, answer a question, I had something go wrong at my plant, this breaker failed, there was a lightning strike, whatever, what are the downstream impacts of that issue? You know, what things turn off if the breaker trips? That is an answer that you can find laboriously by tracing a whole bunch of one-line drawings and P&IDs and whatever else you need to do. That could take hours, it could take weeks, depending on how complex the questions are. And that's something where that research task can really be compressed when you have the right information retrieval. If you are trying to make some sort of judgment about things, does this change that we're making trip any of the 5059 criteria? You need to have access to the full licensing basis of your plant including all the drawings, all the P&IDs, etc., to be able to understand that change properly and say, okay, we're only doing this thing that's not even described. It's below the level of detail, no big deal, or whatever the case may be. And then you need to be able to output some sort of report or document or paragraph, whatever the nature is, based on that. So this is where it gets into maximizing your documents, whether it's a scanned PDF, actual paper document or drawing or print that you have lying around your office. Plenty of facilities still have things on paper, or microfiche. I've spent a lot of time on microfiche. Or you have a nice database with structured data. You have to be able to pull all that information out. And so a lot of things look like the thing on the left there, with a mix of typewritten information, handwritten information, something that somebody scribbled out and replaced back in 1983. And these are the sorts of arguments that you get into, whether internally or with the regulator, to say, you approved it that way, I'm fine. No, I didn't, prove it to me. And so these sorts of details, whether it's on drawings or on documents, really matter. And if you can't pull that information out, you may as well just pretend you burned your file cabinets down, because you can't get to it and it won't help you with the next generation of questions you have to answer. So structuring that data and being able to make it accessible is key. And that's where we get to really maximizing the information in your diagrams at your plant so that you can do powerful things with them. The example on the left there is for one plant's license renewal boundary drawings. So at the stage where a plant goes through license renewal, they're marking up their drawings and putting in the boundaries of where are my safety related systems, where are my systems that could affect those. The red lines versus the green lines have really important meaning. There's black lines too. People spend months going through these drawings and saying, okay, what components are on these drawings? Is it a red line? Is it a green line? What do I do with that? And then how do I treat these components moving forward into my period of extended operations? When you have AI tools that can read these drawings reliably and say, this is the component, this is its ID, these are the things that it's connected to upstream and downstream, you can accelerate that sort of workflow of understanding what components are relevant for a particular process. You can do simpler things. You can play Where's Waldo with the drawing. Where's valve number 927 Bravo? I don't know, that drawing's too complicated. I'm going to spend 20 minutes trying to find it when an operator is breathing down my neck. If you can just type it in and pop it up, so much faster. And then you can talk about even more sophisticated things, extracting information so that you can do simulations or operator training or digital twins, all of these things. There's so much knowledge locked into these documents that you can then use, whether it's chatting with it to answer a question or building a sophisticated model afterwards. So we are at the early stages of this at my company. Others may be doing other things, but we see so much potential here to be able to take a flat paper-based plant and then really bring it to life in a way that is, when you're walking around the facility, those of us who've done that, we know what it's like. But bridging that gap is going to be key, especially in the future where we are losing people who really have that knowledge of how the plant operates. So just super excited about that. I think I have one more slide. Oh yeah. One more thing just to mention, in case, like I was telling you about before, like it's not just hitting the button and operating the power plant. There need to be people in the loop for all of this stuff. So whether you're extracting data from a drawing, you're doing a chat with it, you're outputting a whole license application in a few shots, the citations, being able to approve it, being able to have confidence in the results, that's a key piece of it and something that we'll probably have questions on afterward. So next slide is my last slide. I really appreciate being here. I'm looking forward to the Q&A stage. This is a zip through the idea that you really can maximize your output and maximize what every person on your team can do if you're able to extract information in the way that I was talking about. So, Gabby, who's next?
Thank you. Thank you so much, Teresa. Next up is Archie.
I am super excited to be here with you today and share this virtual platform with the other panelists. This is a very fascinating topic, and happy to kind of provide Microsoft's work in this space, and talk about this really important topic. Just to orient the folks on the call, the Microsoft piece is going to be two parts. I'll be doing the first part, and my awesome colleague Nelly is going to be doing the second part. I'll be digging into why are we looking at nuclear energy and what role nuclear energy plays in our energy strategy. So I think that's kind of important to understand why we're also looking at AI tools to streamline nuclear energy and its potential deployment. So this is a really important topic and a very timely topic, not only for our industry, but for our planet. How do we get to reliable energy sources? What role does nuclear energy play in that? And also, how can AI help it? So the world is demanding more and more clean energy, and nuclear, paired with AI, is positioned, I think, uniquely to deliver and meet that goal. So without further ado, let's kind of dig in. So before we jump into nuclear technologies and our view of how we look at it, maybe it'll be worthwhile actually to kind of look at how Microsoft views energy at like the high level, and kind of be helpful to position ourselves first in that and then jump into some of the details. So we are a tech company, that I think is very obvious, but we're not just a tech company, we're also a major energy consumer. We're also a collaborator in clean energy transition and an innovator in clean energy technology. So just to kind of dig in a little bit more, as a consumer, our demand is stable and significant, which means that we have a real stake in how energy is produced and managed. As a collaborator, we're working with partners across the industry, across the globe, to support net zero commitments and procure 100% renewable energy. And lastly, as an innovator, we're developing AI solutions that help utilities, energy providers, users operate more efficiently and sustainably. This is a multifaceted approach, which gives us a very unique perspective and also a responsibility to help shape the future of energy. So all that's great, but how do we actually make a difference? And the way to think through that is in three main ways. First, we operate for the future. So connecting and maximizing existing assets securely to boost profitability and productivity. Second, we're committed to getting to net zero, which means reducing emissions, decarbonizing the grid, and optimizing renewals. And third is we are unlocking sustainable business models, putting ESG, environmental, social, and governance at the heart of innovation. So it's not just about technology for technology's sake. It's about using these tools to create real lasting change for us, for our customers, our community, and the world at large. So how do we see our impact? So what is the opportunity for us to make the impact here? And we see it as huge. So we're taking care of not only our environment footprint, but we're also delivering digital technology that helps reach net zero. If you think about it, it's enabling a more sustainable world. We're not just helping ourselves, we are helping our customers and partners to do the same. And in that framework and vision, we see advanced nuclear technologies playing a really important role. A big part of that story is our understanding of what role nuclear technologies, maybe fission or fusion, can play in it. So these technologies are of importance to us, and because they are accelerating the availability of new carbon-free solutions. And they're also helping us create the societal conditions that are needed, not only for net zero economy, but energy for all, and kind of create equity in that space. Okay, so let's talk about advanced nuclear and why we think that is important. So what you see on the screen here is our policy paper on how we view nuclear energy and how we view fusion technologies and what role they can play in our energy portfolio and our vision of the future to get to carbon-free future. It's a publicly available document, but I'm going to summarize it a little bit and give some perspective there. So both advanced nuclear and fusion technologies, as everybody here on the call knows, are firm carbon-free resources, very important. They have the potential to dramatically increase energy capacity, decarbonize our energy systems. And these technologies are also rapidly evolving. There's so many unique designs and use cases in varying degrees of design maturity and licensing. So we see a lot of potential there. But they also face unique challenges, let's say in regulatory space or deployment space. So if we want to fully decarbonize the grid and maximize the use of these technologies, we need a range of solutions. So that's why we are very keen on having a multi-technology approach where nuclear plays a really important role. And not only are we using our energy side of discussion for nuclear, but also using our expertise in cloud and AI to create the right tools to bring these technologies to market sooner, safely, and reliably, and not just first of a kind, but through multiple deployments. Okay, so just a little bit of insights into how we look at our work in this space, especially in the advanced nuclear realm. So it's not just about technology. Technology is really important, and I think it's just really fundamental, but it's also not enough by itself. Government policy plays a huge role in enabling and expanding advanced nuclear. We need to advance research, development, and demonstration. We need to enable the safe deployment of new technologies. And we also need to ensure that deployment is cost effective, it's safe and grid optimized, and that it is actually an outcome that is supported for all and most of the global deployments there. Lastly, but not least, is local considerations are also key. So how are communities looking at this technology? So policy needs to be flexible and responsive to local needs. And our vision is not just about the advanced nuclear technologies, but how do we create the societal acceptance, if you will, and create the tools to make that happen. Okay, so there's a lot going on in this slide, and I'm not gonna drain it, but I'm just gonna give a few touch points or insights on how we are progressing in the nuclear world and our interactions with the industry. So it is not just that we have a policy, but we're very engaged in the industry. We've published the policy brief, as I said, on advanced nuclear and fusion. We have launched the Advanced Market Commitment to build demand for clean energy. We've joined the EU's Small Modular Reactor Industry Alliance, and that aims to accelerate small modular reactor deployment. That one is focused in Europe, but we're also very much focused in the US. We have the first power purchase agreement for fusion with Helion Energy. And we're very proud of the work that we have done on the Crane Clean Energy Center restart. That is progressing beautifully and has brought clean net energy back onto the grid, which is amazing. So one of the things that's important in understanding our larger strategy is it's about strategic partnerships. So it's about smart regulatory strategy and working together with the industry as we go forward. Okay, so this is very obvious to everyone, but I think it's important to kind of spend a little bit of time on this, and this will be a good segue to the AI tools that we are creating. So all nuclear is good, but not all reactors are created equal. So the way that we look at the opportunity and the possibility of advanced nuclear technologies is very nuanced and granular. So we are very keen on understanding microreactors, for example, small modular reactors, may they be Gen 3 or Gen 4, and even large-scale reactors. What do deploying these look like? And what do they bring to the market, to us as a hyperscaler who is in need of clean, firm power? So each are designed for different requirements and have unique use cases. Microreactors are great for remote locations and smaller grids. SMRs are more flexible and scalable. Large reactors have been very reliably providing baseload power for us for decades now. So it's very obvious that it's very, the key thing here is design maturity, testing, validation, all of the things that we are in the industry have experienced. But one of the things that is also important is the regulatory pathways for deployment. How confident are we that these technologies can come to market, get licensed in an efficient and repeatable manner, that we can not only think about the first of a kind deployment, but really count on them for future deployments for decades to come? With working with the experienced partners, we have realized that one of the key bottlenecks, one of the key bottlenecks is licensing. So something I think Teresa said it brilliantly. I think it takes so long to get licensing done, and it is often something that takes years, and it's very iterative and sometimes very circular in nature. So we have found that one of the big challenges is licensing and the amount of time, resources, and reputation that it takes to get a licensing effort cleared. And this is not just for advanced nuclear. I know it's sort of like site involved also. So here's one of the ways that we at Microsoft are working and understanding how our tools and our expertise in AI can help really reduce the time it takes to get licensing done. Why, not only on the cost and time, but also without compromising quality, accuracy, or completeness, because nuclear is not going to do without those. So how do we maximize and amplify our SMEs' time? Start with a more completed or more more complete licensing document versus starting with an annotated outline, for example. So if you can just imagine what it would be like working with the regulators and licensing application developers together on these AI tools that streamline documentation, spot missing information, accelerate approvals, and maybe really complicated design approvals or site approvals, or working them together. That is the transformation we're working on, and we really need to actualize the nuclear renaissance that we're working towards. This is one of my last slides, and then I know you are all probably waiting to actually hear more about the AI tools, which Nelly is going to cover, but a little bit more about the licensing AI tool itself. It's kind of something that I have worked on and have experience being on the other side of the industry. So I'm very keen to kind of show you the work we've done here. So how does AI actually help with permitting? You know, we're talking about agents, AI-powered tools that allow SMEs to start with really large document sets. So the more information and the more data sets you give, you get the better information, first drafts, which is pretty obvious. As much information you give is basically the level of detail you're going to get back. And it's going to draft sections and complete licensing submittals, maybe topical reports, environmental reports, and so on and so forth. And the documentation and the automation of it is really very, very efficient in the sense that it cuts down on the iteration needed. And the best part is that it is extendable. So the more information you add, your first product is going to be just as smart and faster and more reliable. Okay, so this is just a kind of what our vision for going forward looks like. So it's more innovation, collaboration, and advocacy. So we are building the tools. You're going to hear more on what the AI tools are, besides the licensing permitting solution that we have created. And we really see it as a very transformational effort to bring advanced nuclear solutions to market sooner so they can be cleaner and you can rely on them in a more predictable manner. So I think Gabby, I think Nelly's next. I really look forward to your questions and thank you for this opportunity.
Thanks, Archie. Yep, and we'll be moving on to Nelly for AI for nuclear.
Thank you. Thank you, Archie, for teaming me up, and of course our organizers for having me on and talking to all of you. I see all the questions, and I'm happy for our very involved and excited audience, so please keep the questions coming. But I will continue with talking specifically about AI and how do we see AI not only with our customers from the nuclear perspective, but also how we at Microsoft have been deploying AI. And my role is really about understanding the use cases, scenarios, and requirements of our customers within the federal space, and mapping those to specific solutions and specific AI capabilities so we can maximize the ROI of them actually deploying and implementing AI within their environments. So when I talk to our customers across the federal space, they have been different ideas about the AI, right? Some of them would say that AI is new, but then others would be more involved in how the evolution of AI has been happening. So what has really been new is not really the idea of artificial intelligence, which has been around since the 50s, or if you are a science fiction reader, that like I am, the idea has been there long ago, a couple of centuries back. But the real evolution that has happened with the AI and what has created the buzz that we are having nowadays is the generative AI. The AI that not can just do what machine learning does with understanding the patterns in the data, but rather also create new written, visual, or audio content given your prompts or given existing data. But we're already moving a step ahead and after the just generative AI and thinking and talking and implementing agentic AI. That is what the new and the latest iteration and evolution of AI is. And the agentic AI is really about not only creating new content, but also having AI do some of the tasks on your behalf. And that agentic AI is already is giving us some transformation, both within Microsoft and also with our customers. Within Microsoft, all of our employees have access to Microsoft 365 Copilot as their AI assistant that can help them be more productive and really save time on everyday tasks. We are really kind of reinventing our customer engagement because all of our support engineers, for example, now have access to their own copilots that help them triage the requests and answer the customer support tickets much faster. But also we are accelerating innovation both inside Microsoft and also helping our customers. I'll give you one statistic. In the past 3 months, in the past 12 months, actually, we have put out more features and capabilities within our products than we did in the past 3 years combined. And that is because about 30% of the code written within Microsoft is written by our developers with the help of AI. So that is helping us to innovate faster, quicker, and give our customers more features and capabilities that they need within their environments. We're also helping in terms of advancing science. I will bring an example from one of the national labs under the Department of Energy. We have worked with them on finding a new material for a battery that in traditional wet lab would probably take about 10 years, but with the help of high performance computing and AI, and of course the brilliance of the lab scientists, it has taken only a few months. And the implications of that can be tremendous, right? More efficient batteries that are cheaper to make, and of course that will further help with energy, or also in building new electric vehicles that will be more efficient. And this is how we are really seeing that how agentic AI is shaping our work and also the work of our customers. We're seeing this, that the work of yesterday is really all around information silos where data is moving slowly. There is very rigid or very little automation going on. But we are starting to move, and we are moving towards more this human and AI agents-led environment where information moves fast. There are no silos. There's more integration between different divisions of the organization, and agentic AI is helping you to adapt to more complex goals. Next slide. And we are seeing this happening in 3 phases. And what we're calling also, this is the move to a frontier firm that is adopting AI in a meaningful way that is helping their business and mission. And this phase is also, they are not just plucked out of thin air, but this is based on the interactions and the research and our efforts across 200 customers across the world. So first phase really here is we're seeing of adopting AI or agentic AI, we're seeing the human with an assistant. So every employee has their AI assistant that helps them to be more productive, to work better, faster, and that is that generative AI assistant that I talked before. Phase 2 is human-led agents. So agents are joining teams with your employees, and they are taking on some of those tasks at humans' direction and doing those on humans' behalf. And that way, again, you are becoming more productive in a shorter amount of time and becoming more efficient, while the agents are taking care of the more, let's say, menial day-to-day tasks. And phase 3 is the human-led and agent-operated setting, where you have a multi-agent, complex agentic frameworks that are running the entire business process or a workflow, and the human is directing or checking in as needed. So these phases can happen either sequentially or also at the same or in parallel. It really depends where you are starting as an organization and how you are moving through those phases, and some of them can happen at the same time depending on different divisions also within the organization. So really the idea is here that AI has created a lot of hype, right? And we are always in conversations that with some of the customers saying we want to implement AI, but the idea is really to innovate with purpose and finding out what those use cases are where you want to effectively and securely apply AI and not just follow the buzz. And this is where we are talking specifically about how to go about implementing AI securely and effectively. I hear questions very often whether this or that model is available within our portfolio. And this is when we are recommending customers also to move away from the idea of models, but rather think about your mission. What is your use case? What is the scenario? What is the problem you are trying to solve? What are the requirements for your specific organization? And then think about the platform where you are doing your AI innovation. It's not really about the models. Models will come and go every week. The model that is popular now may become obsolete tomorrow. But your use cases will remain and they will probably evolve. And for that, you need a platform that can allow you to choose from a variety of models, bring in your use cases, bring in your data securely, and then innovate, test, iterate, evaluate, and then continuously monitor, right? It's very important to also consider the security. What is how you are handling data privacy, security, the compliance with a number of different regulations that you may have within your industry, right? Someone in the chat asked a question about specifically NQA1 standard, for example, right? And that's about the nuclear quality assurance. How AI can help with NQA1. And in those, this is where we are really thinking about how you are controlling your AI solution, how you are enveloping it in a security framework that would make sure that your data is secure, you are compliant with the regulations. And I want to make sure that we differentiate between AI tools that are for mass consumption, think of ChatGPT or others that are really for public use, and the AI tools that you can build and control yourself, for example, on Microsoft Cloud. Because in that case, you are completely in control and you can make sure that you are designing and inspecting and evaluating your AI solutions continuously and continuously monitoring them while they're also safe and secure. And here some of the use cases that we're seeing that are applicable within the nuclear space with AI. So predictive maintenance really is how you can use AI to analyze, for example, the condition of your sensors, your equipment, right, and assets to make sure you are identifying the probability of failures and staying ahead of those, anticipating potential failures, and really optimizing your maintenance. And the benefits for that, of course, can be increased reliability, reduction of costs and increased safety. Another use case that we're seeing, and this is not, again, these are not just ideas of use cases, these are real scenarios where we are working with customers across the world. Streamlining demand response with AI is really about forecasting energy consumption, right? Based on whether it's weather forecast, grid conditions, or understanding what the peak demands may be in specific periods. Energy trading with AI is another potential use case that you can consider, where you're analyzing various factors that may influence energy prices. And I talked about security. Security is always on top of mind, and AI can also help enhance your cybersecurity posture. You can continuously monitor your network activity, recognize patterns in a much easier and natural way with AI, rather than going through all of your different logs separately and manually. So this is one of our exciting collaborations with the Department of Energy's Idaho National Lab around permitting and licensing. Archie mentioned that we have developed a solution that can accelerate the licensing and permitting process, and that we're seeing there's a bottleneck not only in the United States but also in other geographies. We have partnered with the Idaho National Labs to deploy that solution within their environment, and they're now using it specifically for generating nuclear safety analysis reports. The solution can help with, as Archie mentioned, with document generation. Think of those large 100, 200 plus page documents that need to correlate information and data from number of different data sources that are disparate, they're different data types, and that helps you generate, for example, an environmental impact assessment within 5 to 10 minutes, rather than spending maybe months on writing the 200-page report that NRC or others may require. And of course, another aspect of this is the review portion, where you can review your documentation against specific set of questions or requirements that you may have. Similar deployment and implementation of the same solution with the Lloyd's Register, who are using this application to advance their work with nuclear technology in maritime situations. These are the examples I can bring. These are the examples that are public, but that solution is also being deployed and implemented with a number of other customers who are seeing also savings, time and cost savings from 25 to 75%. And that's, I understand, is a large range, but that is because they are deploying and implementing it in different ways and using maybe one section and instead of using all three features that it may have. So I want to quickly also talk about what are those agents, because I started talking with agents, and the solution I mentioned that Idaho National Lab is deploying is also an agentic framework. So those agents agents can be on the spectrum, and that really depends on whether you are doing a simple retrieval of information, whether you are giving your agent maybe one task to execute on your behalf, or this is more of an autonomous agent framework that is executing complex business workflows, and you are directing and checking in as necessary. So what do you need to successfully develop your agents? This really correlates with what I mentioned previously about successfully implementing AI, is really having the knowledge. What is the use case? What is the data that you are providing your agents to work with in that right context, right? What are the actions? Give them the tools to complete their tasks. What kind of actions do they need to do? And then making sure that your agents are working in a secure environment, and you have all the tools, for example, around your data governance, your data security, compliance, authentication in place, and then having that framework for continuously evaluating your agentic frameworks to make sure that they are correctly completing their tasks and performing as needed. And all of those factors are available and can be done within our Microsoft platform. Okay. So we are really thinking about how to apply and innovate with AI in a meaningful way, and how you are moving. I said that we should move away from models and think about the use cases and the platform. So, and how you can go from the use case to actually reshaping your mission or business processes to make sure that you have that. Can we go back? And understand what is the feasibility of the projects that you are doing, right? And understanding the ROI. So when you are as you are starting your AI project, think about the use cases, understand what are the priority, how do you prioritize those use cases in the myriad of many that you may have, how you are going to measure the success of those AI use cases, and what is the ROI and the feasibility of implementing those. So to make sure that they are actually useful and valuable for your mission. And next, which is the last, really is like, let us know if you have any questions, put them in a Q&A or reach out, and I'll be happy to talk to you about how our teams can help you in your deployment of AI. Thank you.
Thank you so much, Nelly. That was great. Thank you.